Our next example is to determine the electron and molecular geometries of each molecule. So our first molecule is N2O, where oxygen is terminal, meaning it is at the end. So we have our two nitrogens and our oxygen at the end. Now nitrogen is going to have 5 valence electrons, and oxygen has 6. So we have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and then 6 on the oxygen. Now we need to figure out how to bond these so that all of the atoms have their octet fulfilled. So it looks like from here we have 3 possible shared electrons here, and then a single bond here. So this is going to look like this. So we have our nitrogen with a triple bond to another nitrogen, which is single bonded to an oxygen. Okay, so our first nitrogen, it only has 6 valence electrons, so we need to add 2 more to make it full and happy. Our nitrogen in the middle has 2, 4, 6, 8 electrons, so that's fine. And our last one, oxygen, only has 2, so we need to add 6 more. Now the electron geometry and the molecular geometry, we need to look at the central atom. So for the electron geometry, we look for the number of electron groups. So in this case, there are 2 electron groups. And the molecular geometry deals with the number of bonding groups. And in this case, around the central atom, there are also 2 bonding groups. So when we look at our chart from this chapter, we will see that if the electron geometry has 2 electron groups, then it's going to be linear. And then the molecular geometry, if there's 2 bonding groups, it is also linear. And you can see this visually because the nitrogen, and the oxygen are lined up in a line. Our next example is going to be our SO2. So oxygen has 6 valence electrons, and our sulfur has 6 as well. So the oxygens, there's 2 of them, so we're going to have sulfur in the middle between them. So we have oxygen with a sulfur, another oxygen, and now each of these atoms has 6 valence electrons. So we'll do 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Now we need to figure out how to bond these correctly so that all of the atoms have their octet. So it looks like if we go from left to right, we can possibly share 1 set and 2 sets. So there's 2 sets of electrons that can be shared between the oxygen and the sulfur on the left. And on the right, it looks like if we pair this lone electron here to here, we can then connect them like this. So we're going to have our oxygen double bonded to our sulfur, which is single bonded to our oxygen. And then we just need to add our missing electrons. Okay, so for electron geometry, the central atom has 3 electron groups, 1, 2, 3. So this is going to be a trigonoplanar geometry. And then our molecular geometry, there are two bonding groups. So we count the single, double, or triple bonds. So there's 1, 2. So since there's two bonding groups with an electron geometry of trigonoplanar, our molecular geometry is going to be bent. Our next problem is H2S. So let's draw it. We have two hydrogens. So we're going to have our sulfur in the middle between those two. So hydrogen, sulfur, and a hydrogen. Now hydrogen only needs 2 valence electrons to be happy. So we can just automatically bond those together to the sulfur. And then sulfur needs 4 more electrons in order to fulfill its octet. So we have 2 valence electrons for each of the hydrogens, making it happy because it's a duet. And we have 2, 4, 6, 8 sulfur on the sulfur to make that happy. Okay, so in this case, for electron geometry, we have 4 electron groups. So we have 1, 2, 3, 4, which means it's a tetrahedral. Next, our molecular geometry. We have only 2 bonding groups, since there's only 2 that are single bonded. Now, since it's 2 bonding groups with a tetrahedral, it is going to have a bent molecular geometry. Our next problem is going to be PF3. So we're going to have our phosphorus surrounded by 3 fluorines. Like that. Okay, so phosphorus already has 6, so we need 2 more to make it happy. And then each of the fluorines, we need to add 6 more valence electrons in order to make the octet for all 3 of these. Okay, so now for the electron geometry, we look at the central atom and the number of electron groups. So we have 1, 2, 3, 4. So this is going to be a tetrahedral electron geometry. And now for molecular geometry, we look at the bonding groups. And in this case, we only have 3 bonding groups, which makes it a trigonal pyramidal. Trigonal pyramidal.